Just to clarify for everybody, so in yesterday's class, we kind of failed to figure out for powers of 3, but now it's clear that even with powers of 3, it is possible to solve the same problem by using the Roman method. Yeah.
Sir, question.
Yes. इतना खींचने की क्या जरूरत है? Yes, please speak. Whoever wants
So,
to.
Pranav, and I have to say something.
Who is I? Now is fine. Who is I?
So, Pranav.
Can you just give your names so that I can make a sequence of people who want to say something?
So, Pranav.
One is Panav, then
Mudit.
Ninesia.
who's that? Ninesia? Did Ninesia want to say something?
Yes, sir.
Yes, then? That's it? Okay. Go ahead, Mudit, Panav or Mudit, or anyone.
Sir, I think the Roman used two because if you see like this, the Roman multiplication,
Yeah.
it's as it is, it's time taking from the normal multiplication. So
Yeah.
they didn't wanted to make it more time taking and complicated. So I think they did it with powers of two because it was easy.
So the first point is that powers of 2 are easy because doubling numbers is easier than doing anything else, including tripling numbers, right? When you double the number, all you have to do is you have to add the same number to itself. Then you easily double it. Okay? And it's possibly something that you can even do in your mind. But even tripling a number is not so straightforward. Okay? So we come to that conclusion that possible reasons. We are like thinking a little bit about the history of mathematics now, okay, and trying to formulate our own responses. So one of the reasons why we can see easily that powers of 2 is useful is because doubling numbers is easy. First factor. Yeah, any other ideas?
Sir,
Yeah, Mudit.
actually I don't know how to take the powers of 2 and all. So can you just tell me?
What do you mean? You don't know how to take powers of 2?
Yeah,
Sir,
actually,
he is asking what is powers of two and all that.
yeah.
Maybe you do not know this because this is something that you actually come to learn a little bit later. Maybe in 7th standard, but definitely in 8th standard. There is a branch that, there is a topic in mathematics which is called indices, which deals with the powers of numbers. But squaring, cubing, you must have done before. Squaring numbers, cubing numbers. You don't know?
Yes, sir. Numbers and practical numbers.
Have you dealt with this in the last year, or people do not know? Has this been taught to you?
Yes, sir.
Yeah, like 2 to the power of 2,
Algebra.
3 to the power of 2, 4 to the power of 3. Things like
It
that.
means 4 into 4 into 4.
Yeah, exactly. This is a way of just simply writing 4 times 4 times 4, or 3 times,
Oh,
or 2 times.
okay, I understand, sir.
Yeah, it's a very
I
simple,
understand.
nothing complicated about it. So we say that
Okay.
this in India we call, I don't know whether just in India, maybe in other parts of the world also, we
Raised to the power of 2.
raised to the power of 2. So we say 2 raised to the power of 2. That's not mathematically accurate. We don't call it like that. We call this as the indice. Okay, the exponent. All right, but you will come to that later. Right now, we can still talk about it as power of 2. So is it clear
Sir,
now?
I understood. Yes, sir, totally.
Okay. So then Ninesia.
Sir, the calculation you did first was wrong.
Which one? Where?
The first answer you rubbed it.
It agreed with this 2451.
No, sir, it's not the answer.
It was correct only.
27,
Yes, sir.
27 times 43 is wrong. So sorry, 57 times 43. 245 only it's showing.
Yes, sir. It is 2451.
Nainisha, where did I go wrong? Can you be more specific? I might have done something wrong, I don't know, so just correct me.
So when you added all the numbers 1176, 400 and all those.
Can you tell me the numbers again? I might have made a mistake with that because I did a little bit of cheating in the background. So it may be possible that I made a mistake. You tell me what those numbers were.
1176.
Okay. Plus.
488.
Okay. Plus.
44.
Sorry, what 44? 244. Yeah.
2
Plus 43.
and 45. 45.
No, it would have.
Sir, it's right, sir.
Yeah, I don't think I wrote 45. Maybe the way I wrote 3, you thought it was 5. That's my bad, my mistake. Because I know this, because my father used to complain to me because he used to teach me maths. I used to write 3 and 5 very similar to each other. So he used to complain. So now it has come back to haunt me. I have to tell my father today night that a child made a mistake in my class because I couldn't write 3 and 5 distinctly. But this is supposed to be 3. Then I think it will add up correctly. Fine, Nainisha? Because 6 and 4 is 10, 10 and 8 is 18, 18 and 3 will be 21. So it works out right because it comes one here and one here. Are you satisfied?
Yes.
Okay.
Sir, video is pausing.
Sorry?
Sir, video is pausing.
I didn't understand that. I couldn't make out what you were saying. Video is pausing.
Your video.
Okay, yeah. Maybe because of my internet connection or your internet connection for one reason or the other.
So,
Yeah.
Sir Panav, I have to say something.
Yeah. Yes, Pranav.
Sir, I think I got one more reason because why did the Romans use 2?
Yeah.
Because mostly people start with small numbers and they surely know that they couldn't do it, and so they can start with 2, and
Yeah.
it worked out, so they didn't need to try till 3, 4, 5 and all that.
Yeah, but I think that is part of the same reason, but maybe it's useful. So can you tell me clearly what is your point? They started with a small number and since it worked with that small number, maybe they didn't think of.
So usually we start with like if we want to do some, we start dividing it with small numbers or something like that. So they also, I think they started it like that, and they saw after doing 3, 4 sums that 2 is working. So
Yeah.
I think they didn't bother enough to go to 3, 4 while 2 is working. So
Yeah, it's tempting to come to that conclusion, but I would say that a maths teacher and some maths student, when they saw, I'm talking about me and you all, when we saw that it is possible with powers of 2, automatically the question came to us, why not powers of 3? And who knows, maybe I thought that maybe powers of 3 could be easier than powers of 2. But after all, 3 is a bigger number than 2, and you're talking about multiplication. So maybe it's possible for us to do it with 3 also and make it work. We did make it work, but then we saw that it was easier with 2 than with 3. For the reason that is mentioned over here. So maybe I can put that 2 works for all numbers. Can I say that?
Yes, sir.
Yes.
Yes, sir.
Yeah, because using 2 and multiples of 2, I can break up any number into different parts. You can also probably do it with 3, but if you combine both these factors, you can do the same thing with 3 also, but tripling numbers becomes harder. Okay, so anything else suggests itself? There isn't any specific answer to this question. I'm just asking us to think about it. That's all. Okay. Let us also have some fun thinking about mathematics. Why do we think these people did this? I think I have one more reason. Shall I say it? Hello? I said,
Yes, sir.
yeah. So, the other reason that I think why this method would have been sufficient for the Romans, okay, is that in those days, why would you require to find out the multiples of very large numbers? I mean, a number like 57 times 43, okay, I can still understand. Let us say that they had, 57 parts of what? Okay, 57 plots of land.
And they wanted to divide it into 43.
This is not dividing. This is multiplication.
Oh, multiplying. Sorry.
So let us say, I'm just completely making this up, okay? So let us say that there were 43 noblemen in the Roman Senate, senators. Okay, you can't see that, no? Yeah, 43 senators, and each senator had 57 plots of land. So maybe you wanted to know between these 43 senators, totally how many plots of land did they have? Okay, this is something that I can still imagine as a possibility. Okay, or let's say that 43 fishing vessels went out to the sea, fishing boats went out to the sea, and each fishing boat
Each got 57 fishes.
something like that. That seems a little strange. How will each boat catch 57? Or maybe each boat cost.
So that's a bit strange.
Yeah, that's right. So I can say that maybe 43 boats went out to the ocean, and each boat cost 57 shestri. I think that's the currency that they used to use. Okay, so then how much money? And let's say all 43 boats got sunk. So how much money did the merchant lose?
Money was wasted.
Money was wasted. So, but how do I find out? Do I add 43 57 times, or do I find a way to multiply it? Okay, so the point that I'm trying to make is that Nainesha, did you lose a lot? Nainesha, did you lose a lot, or you are able to follow still? Oh, again she went out, I think. Okay, so but the thing is that these are the kinds of numbers that the Romans might have dealt with. They wouldn't have dealt with numbers which are in the millions and billions, that like the way we have to nowadays. Okay, so for that reason, I think the multiplication operations that the Romans had to carry out was not very large operations. So for numbers which were still in the region of tens of thousands or hundreds of thousands, the products that they required could still be handled with 2 as being the base number. Okay, so I would say that the fact that they did not have very large multiplication operations to do may be one of the reasons why they did not think of larger numbers than 2. Does that make sense? Can I put it as a reason, or you people think it's not?
Yes. Sir, I have a question.
Yeah. Shall I put that as a reason, or your
Sir,
question has got something to do with that reason?
sir, no, sir, my question is something. Sir, in this Roman multiplication, is there a specific person who created this?
I don't have information about that. I doubt if we have any information about that. Uh, Obviously, there must have been somebody or a group of people who might have come across this method. In those days, usually a single person only comes up with these kinds of things. But I don't know if we know who this person is. In fact, I don't think I know any Roman mathematician actually. I don't know. I'm sure there were many, but I do not know. The name Seneca somehow comes to mind, but I'm not sure. Seneca.
Sir, your video is pausing.
Okay. Sorry about that, but anyway, if you missed something, just ask me. So I can write then Romans. Oh no, Romans did not have large multiplication problems. Do you think I can put that there as being one of the reasons?
Sir, but how do we know that they did not have large
Yeah. So
multiplication
yeah,
problem?
but because that is how I imagine it. I might be wrong, but I also know, for example, that um, in all of the civilizations at that time, up to that time, in fact, they did not have any reason to use numbers much greater than, let us say, 6, 7 digits. For what reason would they have required numbers greater than that? There is only one exception to that. There is one civilization which is an exception to that, and you will be surprised what that civilization was. But I will come to that a little later. So their mathematics was very closely tied. I'm talking about the Romans in particular. Was closely tied to real world situations, and also commerce. That is business and commerce. There are flies coming on my whiteboard. So that is the reason why I think that the Romans would not have required very large numbers. Why would they need such large numbers? More than 6 digits, 7 digits. But you are correct. It's a guess of mine. I have read a little bit about it, very little about it, but that is my informed guess. If I am proven wrong, okay, that's a different matter. You know which civilization is an exception to that?
No. Romans.
And
Romans.
This is the Romans. We are
sir,
talking.
what
Oh
are
yeah.
you saying? Do you know which civilization?
Which civilization?
Greek.
Imagine
Greek.
used numbers, imagined and used numbers much greater than 8 digits.
Sir, which civilization was that?
Egyptian.
Egyptians, Greeks,
Greek?
Romans, Babylonians, maybe
Greek?
maybe the Incas, maybe the Aztecs. So many civilizations were there, no? But I'll tell you, the civilization is the civilization that we come from. It's the Indian.
Indian.
Yes, sir. It is the Indian civilization.
Indus Valley?
Not just Indus Valley and after Indus Valley also. So basically, Sanskrit texts that are available to us in terms of mathematics, Vedic literature also, there are numbers which are so large that it is unimaginable. So in Alex Bellos's book, no, the book that I showed yesterday, the same book from which I got this idea. In Alex Bellos's book, he says that the Indians had numbers so big that if you take all the number of seconds, not even seconds actually, sometimes slower, lesser than a femtosecond or something like that, Fermi-second. If you take all the Fermi-seconds that has happened since the beginning of the universe, okay, and then you take all the particles that are there in the universe, and all the positions that all the particles have taken from the beginning till now in the universe, and you multiply all of those numbers also, you don't get that large a number.
Sir, that means how did we find that number, sir? Then the whole
It's a
city only.
exactly. So
Sir, perhaps we'll take around 30 lifetimes to find out that number, I think.
no, we don't need 30 lifetimes. They just let their imagination. The only reason that I can think of is they let their imagination run wild. I said, why should we limit ourselves with small numbers? We can imagine numbers as big as they can be. Let them go as big as they can go. Okay, of course, later the concept of infinite came up. Infinite actually is not a number, but basically it says that there is no limit to numbers. So you can go to the furthest extent that is possible. In terms of imagination, you can create numbers even bigger than the numbers imagined by the Indians. But at that point of time in history, it was the Indians who had imagined the largest number that was possible. Okay, they didn't have any particular reason for that. So they didn't say that there were this many particles in the universe or whatever. They just said that that is the largest number that was possible, and the whole thing was possible because of our because of the system of tens.
Indian.
Yes. What do you call it? I forgot suddenly, just as I was talking about it. Tens, hundreds, thousands, 10,000s, right? So just by creating products, that is, you multiply numbers by thousands, and you keep multiplying numbers by thousands, then you get such large numbers. And they had individual letters for each one of these numbers. See, that is why, in a way, our counting system of numbers is unique in the world. I wouldn't say unique in the world, it's different from the international system, right? In the international system, we count in millions, billions, trillions, and so on. But we have lakhs and
10
crores.
lakhs, crores.
Crore. So crore comes from koti. So the word koti.
What?
Koti, K-O-T-I.
Sir, that's a Marathi word.
What does it mean?
Sir, crore only, sir.
Crore. Yes, in Telugu also it is koti only for crore.
Yes, sir. I was thinking, where did I hear this word?
And there is some evidence that we used such large numbers also, because we said that the number of gods in the Indian pantheon, Muppatti Mukkodi. So we had 33 crore gods. More gods than anybody can remember. Okay, so at some point of time in history, our mathematics was way more advanced than the mathematics as per evidence that existed anywhere. There's a lot of proof for that. Okay, so we will stop here with this. I will probably meet you tomorrow with
Sir, I have a question, last one.
one.
No, a statement. Sir, it's not koti, it's coat. Coat rupailu in Telugu.
Original Sanskrit was kot, and then converted to koti, and from koti you may be
Sir,
right.
it's coat. Coat rupailu means crore rupees.
Crore rupees, yes.
Bye, sir.
You are
Sir,
saying
coat.
yeah. So
It's
see you very soon.
K-O-T, not I. Remove the I.